Hi everybody, welcome to my channel Mass Insights. Today I am very happy. Why? Because our channel reached 100 subscribers. See, this has given me very happiness and also it is encouraging me to do more valuable videos for students. Definitely with this encouragement I will make more attractive videos with information, technology and very attractively. Thank you. I am conveying my thanks to all of you who are encouraging me, who are watching my channel, and I am requesting you please encourage me like this in future also. In this today's video, we are going to discuss what is the relation between coefficients of a quadratic polynomial and its roots. This is very important and also I will make you very easy to you. Shall we? To explain the relation between the coefficients and roots of a quadratic polynomial, I will take an example. Please see it, x square plus 4x plus 4. This is a quadratic polynomial, all of you know. Why? Because its degree is 2. Now I am going to find its zeros, its roots, by using method splitting the middle term. Now I am splitting middle term. You know, you have to multiply the coefficient of x square and 4, then I will get 1 into 4, that is 4. Okay, I have to split, I have to factorize this 4 in such a way that if you add those factors or subtract those factors, you have to get back the coefficient of x. See, I am splitting it as 2 to the 4. If you add these 2 and 2, you will get this 4. So this 4x may be split as 2x plus 2x, and the remaining two terms, first and last terms, will stand remains. So 2x plus 2x plus 4. Here I am writing x square. Simply I am writing 4x as 2x plus 2x. Then you will have 4 terms in this polynomial. From the first 2 terms I will take x as common factor, then it will be x plus 2. Similarly, I will take 2 as my common factor from the last 2, and also you will get x plus 2. Now you have 2 terms, this is the first one and this is the second one. From these 2 I will take x plus 2 as my common factor, that means x plus 2 into x plus 2. So if you want to make the value of this polynomial 0, you have to make it equal to 0. Therefore x is equals to minus 2 or x is equals to minus 2. That means this is the 0. It is repeating. Quadratic polynomial will have 2 zeros and this is repeating. Now I am going to establish a relation between these zeros and its coefficients. I am adding these 2 zeros. So minus 2 plus of minus 2. Actually that will become minus 2 will become minus 2 plus into minus will become minus, and the total will become minus 4. That means the sum of 2 zeros is minus 4. Now I will try whether I will get minus 4 by using the coefficients or not. If you see, minus coefficient of coefficient of x by coefficient of x square. From the polynomial you have to take coefficient of x. What is coefficient of x here? 4. So along with minus I have to write 4 by coefficient of x square. See, that is 1. So that is equals to minus 4 by 1 will become minus 4. This sum of 2 zeros and this result of this formula is same. That means you may get sum of 2 zeros by using coefficients of x square and x. So coefficients of minus into coefficient of x by coefficient of x square is the formula to find sum of zeros of the quadratic polynomial. Similarly, I am multiplying two zeros. See, this is the first one and this is second one. Then minus 2 into minus 2 will become plus 4. That means I am doing multiplication of two zeros or product of two zeros. It is becoming 4, and you have to see whether can you get this 4 by using coefficients of this polynomial. Yes, see, constant by coefficient of x square. The constant in this quadratic polynomial is 4. So 4 by and coefficient of x square. See, coefficient of x square is 1. So 4 by 1. You got 4 as your answer. So in both the cases you are getting same answer. What I am going to say is product of zeros of a quadratic polynomial may be obtained by using coefficients of this quadratic polynomial by using the formula constant term. That means this is the constant term by coefficient of x square. X square is the first term and its coefficient is 1, 4 by 1, that is 4. In this way you may establish the relation between zeros and coefficients. We will discuss in detail. The general form of a quadratic polynomial is, that is, ax square plus bx plus c. This is the general form, and where a, b, c are the constants which are real numbers, and also care should be taken that a should not be equals to 0. If a becomes 0, this will become a linear polynomial. Now this quadratic polynomial will have two roots, two zeros. Let those zeros be alpha and beta, like we discussed previously, minus 2, minus 2. Those minus 2, minus 2 I am naming here as alpha and beta. Therefore this ax square plus bx plus c can be written as k into x minus alpha into x minus beta. See, alpha and beta are the zeros. Therefore, if you substitute x is equals to alpha or x is equals to beta, you will get 0 as the value of this polynomial. Where k, you may get some constant, that is k. Suppose if you have any quadratic equation like this, 2x square plus 4x plus 6, suppose, then here x square is having 2 as its coefficients. When x square is having any coefficient, you have to write k. Even sometimes k will become 1, then this will become x square only. So you have come across different types of quadratic polynomials whose coefficient is 2 or 1 or anything. Now I am multiplying k into, this is x into x square minus x into beta x beta. This alpha and beta are Greek letters which are using here, minus alpha into x, x into alpha. See, minus into minus will become alpha into beta, alpha beta. That is equals to k into, see, x square minus, in these two I have x as my common factor. So when you take x and when you are putting minus outside the bracket, total signs will change. This is alpha, actually it's have minus. Since I am taking minus common, it will become positive only. And also in this I am writing plus beta even though it is having minus, and finally plus alpha into beta. Now I will multiply this total with k into x square minus k into x into alpha plus beta plus k into alpha beta. See, you have to compare the result with this quadratic polynomial ax square plus bx plus c. Now I have to compare the coefficients of every term. X square coefficient here is k and x square coefficient here is a. Comparing, okay, comparing coefficients. Therefore, k will become, otherwise a is equals to k. This is the first one, and second one will become b. The coefficient of x is b, so I am writing b here. Here the coefficient of x is minus k into alpha plus beta. And finally, if you compare the constant term, that is c is equals to k into alpha beta. Now nothing to do here, a is equals to k, but here alpha plus beta is equals to, see, minus k comes here and it will divide b, that means it will become minus b by k. I am taking this minus here, so division with k, and this alpha into beta is equals to c by k. That implies to alpha plus beta is equals to minus b by, you got k value as a, therefore I am writing a here, and also here alpha into beta is equals to c by a. So this is the formula. See, what are alpha and betas? Alpha and betas are nothing but zeros of this polynomial. By using the coefficients of this quadratic polynomial, the coefficients are here a, b, c. By using these coefficients, I am going to find sum of the roots, nothing but plus. Alpha plus beta is equals to minus b by a is the formula to find sum of the roots. And also alpha into beta, what is this? Product of zeros. Product of zeros is equals to c by a. C is the constant and a is the coefficient of x square. In this way, you may relate the coefficients of any quadratic polynomial with their zeros. If you solve some problems on this topic, on this concept, then this will become very clear to you. This is the first problem. What is the problem? Find the zeros of the quadratic polynomial x square plus 7x plus 10 and verify the relationship between its zeros and coefficients. First, you have to read the formula clearly and carefully. What is the data given, you have to assess, and what is to be found. This is very, very important. After assessing like that, you have to go into the problem. See, they have given a quadratic polynomial and they are asking the zeros of that quadratic polynomial, and you have to verify whether by using the coefficients of this quadratic polynomial shall we get the sum of those zeros or those roots or not. Now I am taking solution. Okay, see, given quadratic polynomial is x square plus 7x plus 10. You know how to find the zeros. You have to take the coefficient of x square, see here 1, and the constant. You have to multiply these two, that is along with the sign. Be careful. So 1 into 10 is 10. You have to split these 10. That means you have to find factors of the 10. After finding the possible factors, you have to see an addition or subtraction of those particular factors to get the coefficient of x. See, I am writing 1 into 10. If I add or subtract, 1 plus 10 will become 11, 1 minus 10 will become minus 9. Whatever it may be, I will not get these 7. If I write 5 into 2, 5 2s are 10, and an addition of 5 under 2, I will get 7. Therefore, I am splitting the middle term as 5x plus 2x, and the last one constant I am writing as it is, and also the first one. Now you have 4. From the first two, I am taking x as my common factor, therefore x plus 5, and also 2 into x plus 5. See, in this case, again you have x plus 5 as your common from the in the two terms. Therefore, x plus 5 into x plus 2. Since you want zeros, therefore this product should become 0. When it will become 0? When x is equals to minus 5 or x is equals to minus 2. So these are the two zeros. By using the coefficients, and I am comparing this x square plus 7x plus 10 with ax square plus bx plus c, which is the general form of the quadratic polynomial. Then the coefficient of x square here 1, therefore a is equals to 1 and b is equals to 7, c is equals to 10. You know the formula, sum of two zeros can be calculated by using formula minus b by a. Let alpha and beta are the two zeros, then sum of those two zeros, so I am using minus b by a. Minus b by a minus, what is b? b is here 7, minus 7 by 1, that is equals to minus 7. This is the sum of the zeros and also product of the zeros. C by a, just we discussed in the previous topic, c by a. C is the constant 10 by 1, that is equals to 10 is the product of two roots. Now by coming here, sum is equals to, sum means minus 5 plus minus 2, that is equals to minus 7, and also product is equals to minus 5 into minus 2. See, minus into minus will become plus, 5 to the 10. So you are getting same values whether by using the coefficients or by splitting the middle term. So the aim of this problem is, by finding the zeros individually, you have to do the sum and product, and also by using formula you have to find the sum and product. You have to verify that whether these two results are same or not. So we decided that those are same, therefore we verified. This is the second problem. In the second problem, find the quadratic polynomial. We have to find the quadratic polynomial, the sum and product of whose zeros are minus 3 and 2 respectively. Now in this problem they have given sum and product of the zeros, then they are asking the quadratic polynomial. Let the roots or zeros, let zeros or alpha comma beta. I am assuming alpha and beta as the roots or zeros of the quadratic polynomial. Therefore sum is equals to alpha plus beta. Already they have given sum of these two zeros as minus 3, I am writing same value, and also product of two zeros, that is alpha and beta. What is the value they have given? That is 2. After writing these two, you have to write formula for quadratic polynomial by using sum of zeros and product of zeros, that is equals to k into x square minus x into alpha plus beta plus alpha into beta. You discussed this formula for ax square plus bx plus c is equals to k into x square minus x into alpha plus beta. This is nothing but sum of the roots, and plus alpha into beta, this is product of roots. If k is equals to 1, you may take whatever the value for k, then you will get different types of quadratic polynomials. Now that is equals to x square minus x into alpha plus beta plus alpha into beta. Substitute the sum of the roots, value of sum of roots, that is x square minus x into, in the place of alpha beta I am writing this value, that is minus 3 plus alpha into beta value is 2. So x square minus c, minus into minus will become plus 3x plus 2. This is the quadratic equation whose sum of zeros is minus 3 and product of zeros is plus 2. I am taking another problem, that is find a quadratic polynomial if the zeros of it are 2 and minus 1 by 3 respectively. See, care should be taken here. These are not sum and product of the roots. They are giving individual zeros. This is let alpha and this is beta. If alpha is equals to 2 and beta is equals to minus 1 by 3. Okay, you know that if you know alpha and beta, you can calculate, you can find the quadratic polynomial by using the formula k into x square minus x into alpha plus beta plus alpha into beta. Okay, if k is equals to 1, it will become x square minus x into alpha plus beta plus alpha into beta. First find sum of these two zeros. That means alpha plus beta is nothing but sum. 2 minus of 2 plus minus of 1 by 3, that will become 2 minus 1 by 3, that is 3 to the 6, 5 by 3. 5 by 3 is the sum of two zeros and product alpha into beta. So 2 into minus 1 by 3, that is minus 2 by 3. By using these two values, you may substitute here. So x square minus x into sum of two roots is 5 by 3. Here in the place of alpha plus beta, I am substituting 5 by 3 plus of minus 2 by 3. That is equals to, see, x square minus 5x by 3 plus into minus minus 2 by 3, that is equals to, if you take LCM 3 here, if you don't have anything there, that should be treated as 1. Therefore, this will become 3x square minus 5x minus 2. See, this is the quadratic polynomial. You may take 1 by 3 as your common, then 3x square minus 5x minus 2. You may multiply with this constant throughout the polynomial also. In this way, you may calculate a quadratic polynomial if zeros are given. Sometimes they will give you sum of two roots, that is equals to, let alpha plus beta is equals to 5. This is different, something different concept, and you will come to know alpha into beta also, suppose 6. Then you may find individual alpha and beta. How it will be? First, calculate alpha minus beta. You know how to calculate alpha minus beta when you know the values of alpha plus beta and alpha into beta. That is square root of alpha plus beta whole square minus 4 into alpha into beta. I am expanding this one, alpha square plus beta square a plus b whole square plus 2 into alpha beta and minus 4 alpha into beta, that is square root of. Therefore, alpha square plus beta square plus 2 alpha beta minus 4 alpha beta will become minus 2 alpha beta square root of. That is equals to, this can be written as alpha minus beta whole square square root of. If you cancel, you will get back alpha minus beta again. What I am going to say, alpha minus beta value can be calculated if you know sum of this alpha and beta and product by using this formula. After finding alpha minus beta, you may add those two. Suppose alpha beta is equals to 6, alpha minus beta is equals to 5. For example, if you add, you will get cancel this beta and you will have only alpha. Okay, you will get alpha, then substitute that alpha in either of these two equations, you will get beta value. In this way, you may find the values of alpha and beta. So, by using this concept, you may solve different types of problems which are related to coefficients and zeros. So, this is the video today, and if you like this video, kindly subscribe to my channel and don't forget to press bell icon and comment. Thank you very much.